Hi, so I'm going to show you Gearbox today. This is the website, getgearbox.org. And what is Gearbox? Gearbox is a framework for asynchronous job dispatching. So what that means is you write some jobs. Jobs are generally, there's a one-to-one correlation between like a job and a method in your target languages. Jobs can be written in one of four various languages: C++, Perl, Python, PHP. And those jobs they have processes that daemonize, and Gearbox is really just the framework for you subclass a Gearbox worker method class, I should say. And Gearbox gives you a bunch of methods to kind of interact with that job, and it also provides some easy way to build web services around those jobs. So that's what I'm going to show you today, is how to build a web service using Gearbox. Now, while the demo is kind of focused around building this web service, Gearbox is useful without any web stuff involved. So you don't have to use the web stuff. But that's what I want to show today. So here is my terminal, and now let's presume that to start there is a web services API definition for this web service that I wrote as part of the demo. So that web services definition says that I post to this URL, excuse me, and not that one, but that one, and the structure of this kind of request is, I'm going to use curl for demo purposes, that you post some data. This is JSON, and the job gets that data and it does something with it, right? And that something is up to the job offer to decide. And the structure of the URL that we're posting to is like component name, where component is kind of like a namespace for the jobs, and the version of the thing, which versions are there's a correlation between it allows you to version all of your jobs, so that way when you author a job you can have three versions running at once at different version levels, and the name of the resource that you're creating. So that's component version resource is kind of the format of that URL, and we're posting some data to it. And so what we're going to get back is HTTP 202 accepted, along with a status object to track the job that is dispatched to create this resource. So let's do that. So you didn't see the HTTP 202, but I promise me it is. And the point of that is it's saying that the web server is saying, I haven't created it yet, I accepted your request, I'm going to work on it, and it gives you back in the data of the HTTP response this JSON, and this JSON is a status object which is used to track the status of a job. So you see that jobs can have children, so this is the concept of subjobs basically. And you see here, this is when it was created. This is Unix epoch time. What a number of failures that this job has seen so far. Obviously, the job hasn't even been inserted yet, so it hasn't ran yet, I should say. It has been inserted because it's pending. And this is where we can get like retries and things like that. So messages is a way for the job to communicate back to the user what it's doing. So this is just an array of strings, and those could be like kind of like log messages. It's saying, it would give you status updates saying to the user, I did step A, I did step B, oh, I had a issue, warning, there was a problem, I'm going to try this job again in the future, and it would update the failure count and retry. So progress is a number between 0 and 100, kind of telling you percentage complete with this job. The state is pending, or rather the state has a status, which is or a state which is pending. There's actually a complete state transition diagram that Gearbox statuses have, and here's that state transition diagram. You can see that pending. Normally, like in the simplest sense of a job, in the easiest job, it would just go pending, running, completed. And that's actually what this job will do. This is a self-referential URL. So this is a way that you can poll this status object, because otherwise, it just gives you back how you get it again, because you got it when you were making a request to do something. And the last field is a URI to the resource that we're creating. So you can see that a server ID in this example. This is the demo that I'm doing. We're creating a server. and it generates an ID and a URL, a unique URL for that thing that we're creating. So let's curl this URL and the self-referential status URL, and so we can see how the status has changed since time has passed. And you see that the first thing that you notice is that a child job was inserted to be able to complete this job. So that's interesting because Gearbox, the first job just inserted another job to kind of help it complete that. And what else is interesting? The state went eventually to completed. In between there, we didn't see it, but in between pending and completed was running. And now that the state is completed, we can actually fetch the resource that it created. It's worth noting that fetching the URI before the status that created the resource that the URI references is undefined behavior. So you have to wait until this status the state of this status goes to completed before you can actually fetch this thing. So I'm going to get this server. And you see that while originally we just posted, a server name, that one field server, two other fields were kind of auto-populated for us. Now, Gearbox didn't auto-populate these fields. The job author wrote this. And in fact, the job author is kind of responsible for this resource. So Gearbox doesn't do anything to help you manage these resources. It just dispatches your job, and your job's responsible for like getting the ID, like in this GET request, which, by the way, GETs are implemented as jobs as well, although they're synchronous jobs, where all other HTTP methods by default, like put, post, and delete, are asynchronous jobs. And the difference is asynchronous jobs, like you saw here, return statuses, and synchronous jobs, like the GET here, return the actual content. So anyway, the job itself is responsible for kind of managing this this resource. So that means that the job author actually has to deal with things like connecting to a database and sticking this this ID into a database, or this resource into a database, and pulling it out and giving it back to the user when it does a GET, and deleting it from the database whenever the user does an HTTP delete method, and so on and so forth, and updates, of course. So let me now show you a little tool called gbtrace, which kind of does these curls for us for the status objects, except for it kind of prettifies this JSON, and it also recursively looks for all the children. So it will show us kind of the children and all the children of the children, and so forth. So you see, actually, now here's this top level job, and you saw earlier up here that has a child, so it curled that child for us as well. It didn't use curl, but it fetched that child, did an HTTP request for that child as well. And so you can see that since it was a child, it is tabbed over a little bit, and that child had a status message, and so on and so forth. So now let me do another post request to run another job, a third job. You've seen kind of the create job, and you saw the get job. So now let me run kind of the update job. So now I'm going to do a post, and you notice that I'm updating the state, and I'm posting to change the field, the state field, to provisioned, and I'm going to post to the actual URI of the thing that was up here, right? So I'm going to post to that, and I'm saying change state allocated to state provisioned. So let's do that, and I'm going to get back another status object here to track the that update operation. So here's that status object, and now I'm going to actually quickly take a look at the URI of the server itself that we just posted to, and you see when we look at this, it's actually changed from state allocated that you saw up here. See, state was allocated originally. State is now provisioned, and even though we requested state provisioned, so this is kind of like the specification of the web service that I wrote for this demo says that this is how you do an update on that operation. And so now Gearbox, or rather the demo that I wrote kicks off kind of this workflow to be able to implement that state transition. So now you're kind of seeing this is all the responsibility of the job author to do, to kind of say, hey, Gearbox, when you see a user make this status change, this update on this object that's for the state change, go execute this workflow. And so I'm going to run a GB trace, and I'm going to give it a brief output. And you see that it's run a bunch of jobs. And excuse me, the jobs that were run here are there's a whole bunch of them, and you see that you notice right there. I actually waited too long, but there's a whole bunch of these jobs, and these jobs have prerequisites. So I just from a config file can say this job can run before it. Well, let me show you the config file. If we look at etc gearbox orc demo or orc agents, actually, you see that this job has no prerequisites, but this job can't start or be inserted until this job has completed. And so same for this job, but this job only needs this job to complete. So if this one's taking a really long time, but this one finishes quickly, then this job can get started. So and so on and so forth. So we kind of define this DAG in a config file, and the update job that says that was executed whenever we did this update to change the state provisioned. That job loaded this DAG, passed it to the gearbox agents feature, which then executed the DAG, and all of the subjobs, which are also implemented by the job author using the gearbox framework, got the same data as the top level job, and they were able to do whatever it is they need to do to complete this workflow. So you saw me do kind of a brief output. If I give a more verbose output for that whole job tree, there's some interesting things in here. So I wanted to point out that this particular job actually took, right here, you see it took 22 seconds. And the reason why it took so long is because it was having trouble connecting to a downstream service. So this is where kind of where Gearbox shines, is like in this, when your design of your system is like this distributed system with service-oriented architecture, right, where you have 3 or 4, maybe 10 different components that are all loosely coupled, and they all are their own service, and maybe they expose web services, and you have like this top-level orchestration layer that has to coordinate all these services. This is where Gearbox is really useful. So you see here we were like communicating with the downstream service, which is an inventory system, and that inventory system had it was down. Maybe the network connectivity was bad. Maybe they were going through a maintenance window or whatever. For whatever reason, it was unable to connect. And you see failed to connect to an inventory system, retrying. And so you see it actually failed 5 times, but on the 6th time it succeeded. So maybe like they completed the maintenance window and the service came back up. And this is really useful because the user who made the original HTTP request didn't get an error, right? They just saw it take longer than usual, and they actually saw that it was failing to connect, and they got that feedback. But this is kind of the concept that Gearbox uses, is this idea that I'll just accept all of your requests. I'll immediately give you back a status object to track that task, and I'll eventually get to your stuff. But it's really useful for when you have kind of long-running tasks. So this thing's going to take a little bit longer, so I can't do it synchronously. So I'm going to take your request, stick it in a queue, and if there's failures, I'll tell you about them. But as a job author, you're just going to retry. Okay, so that's all I wanted to show you for this demo video. There's a whole bunch more concepts. There's a whole concept of cancellations, which allows you to undo things that you see these jobs start with do. There's also do cancel, which allows you to cancel a job. There is events, so you can say when a job starts, run this other job, or when this job is canceled, run that type of job, so on and so forth. And so you can imagine how that whole event model can allow you to do some really powerful things. I talked about like retries and delays. You can say, and I talked about how jobs can run other jobs. There's a concept of continuations where a job can start working on the status but not complete it, and then another job can later pick it up and complete that status. Or maybe you can have like 10 jobs just to be able to complete one status. Okay, so I'll make more videos to describe all those kind of more advanced features. But I appreciate your time today. Check out getgearbox.org, and feel free to check on that website. There's a link to our mailing list. Send us a message on the mailing list. Let us know of any questions you might have, or tell us how you're using Gearbox. Thanks a lot for your time.